Hi, welcome everyone to the MedStartr Health Innovation Night. Come this way for better acoustics. Come on forward this way. We have finger food over here. We're getting the AV set up. I wanted to welcome our hosts and speakers and kick off the debate tonight on AI will replace your doctor. First, I just wanted to call out, is Alex Fair here? Alex, both people here tonight know Alex Fair. I don't see him when
Maryland's in Miami. The microphone.
Testing 1, 2, 3. So welcome to the MedStartr New York Health Innovation Night for April. Most people here know Alex Fair. So Alex is the founder of MedStartr, and MedStartr was a hub of the innovation community in healthcare in New York. And MedStartr recently founded a venture fund. And so look to Alex and talk to Alex to get tied into the New York Health Innovation Fund, New York Health Innovation Community and Fund. Next, there's Joe Desiderio, the Chief Connector of ConnectRx. Joe, would you like to step forward? I see Joe in the back. Joe, if you like, when you come up here, we'll let you introduce yourself to the crowd. Then is Deanna Dammers here today? Deanna, I don't see her in the cloud, but thank you. Deanna helped us promote this. She's the Senior VP of IR at Kipic Biomedical. And then Tom Arneman. Is Tom here tonight? So Tom is the Managing Director of Hybrid Edge Business Development Consulting in Digital Health and Life Science. And Tom helped promote this tonight. And Joe, would you like to just briefly introduce yourself to our audience?
Sure. My account here. Hi, thank you. Hi, Joe Desiderio. My consulting company is ConnectXR or Connector. I help out with MedStartr strategic alliances, and I'm happy to talk about alliance management and tech and healthcare and how that fits into the health tech VC world or any of those things. So make sure you get some food. Thank you.
Great, thank you. And then we have a volunteer tonight, Octavia Gilroy, who's a recent grad of the Harvard School of Public Health. Octavia, are you coming forward? Would you like to introduce yourself and tell us something about yourself?
Hi, everyone. My name is Octavia. I just graduated with my Master's of Public Health and Healthcare Management at Harvard. Currently looking for opportunities in digital health, public health in New York City. I thank you all so much. Thank you, Steve.
Thank you. And so if you guys know of opportunities, please talk to Octavia. And then now we move on to our speakers for this evening. So one of our speakers is Dr. Ron Razmi, who's here, and he is the founder and managing partner of Zoe Capital, which is a healthcare AI venture fund, and is also the author of AI Doctor, which is the best book from a business perspective about AI in medicine. And I bought a copy here tonight, and Ron has autographed this copy. And so I will be carefully watching everyone who asks a question at the end of the comments. And the best question gets this book. This is our door prize tonight. And so I encourage you to get up and ask your questions at the end. And then also our speaker tonight is Avisha Ness-Aber. Is that how you pronounce it? And he's the Chief Science Officer of MedStartr Direct. Would you like to briefly say hi to what MedStartr Direct is?
Sure. MedStartr Direct is a company that is an offshoot of the main MedStartr healthcare network. MedStartr Direct aims to identify technologies that are able to make a change within the healthcare world and get them to the people, institutions, and places that they can make a difference. So it's sort of like a biz dev connection for oftentimes the companies within the MedStartr VC portfolio to help them go and get proper distribution within the broader healthcare network. And also sometimes we'll deal with companies not within the MedStartr portfolio, but instead identify something with really cool technology and help it get where it can do the greatest good and potentially profit as well.
Great, thank you. And I'm Steve Wardell, and my background is I was the first analyst on Wall Street to focus exclusively on digital health, started the first investor conferences on digital health. And I hosted 70 parties or conferences during that time on Wall Street. Now I have my own consulting firm. I help young companies raise money from VCs in digital health. And I like to say that if there's one thing that we as a community like to do more than build products in digital health, it's to have parties about building products in digital health. And so with that, and I also am the host of a weekly podcast called Digital Health Investor Talk, where we look at digital health issues from an investor perspective and interview guests about what's going on in the product and investor markets in digital health. So with that, I'll now turn this over to our debate between our two guests here, the two speakers here tonight. And so I'll start it off with AI will replace your doctor by 2030. Now, is one of you in the affirmative and one in the negative? Which are you, Ron, would you say?
I would say I would argue against that.
Are you for?
So there's a lot of nuance here. My stance in this overall debate is AI will replace doctors. The 2030 thing is definitely, there's a lot going with that, which we're going to get into soon.
So why don't we start with just make your initial case for the positive of why will AI replace doctors?
AI at its core is a large bunch of numbers, matrices that are designed to help synthesize information. A doctor has to go through a very large amount of med school where they learn so much in the way of new information. They have to memorize everything about the human body, every way to treat the human body. But they can never learn everything. And every day there are hundreds, thousands of new papers, new pieces of information that come out that no individual doctor could ever properly synthesize. And yes, there's emotional connections, there's doctor-patient relationship, everything. But at its core, the role of a doctor is to ensure the health of a patient so that they never have to come back. And what an AI can do is synthesize every bit of information about a patient, every bit of information that we know about medicine and about health, and combine the two in a way to give the proper recommendation to ensure that they never have to see another doctor.
Well, I think some of that is absolutely true in the sense that practice of medicine could be improved. But let me set the context for us that human life expectancy was 35 years old until not too long ago. And through the modern miracle of modern medicine, antibiotics, statins, surgery, cancer drugs, in countries like Japan and France, life expectancy is now 83. In the U.S. is some of the lowest life expectancies in the advanced world. And there are a lot of reasons for that. But the fact is that modern medicine has been extremely successful. I mentioned this in the preface in my book, that McKinsey has estimated that about 30% of the total GDP growth in the last 100 years is attributable to advances in health and healthcare. Now, just to set a context, about 100 years ago, the world GDP was less than $1 trillion. Today, it's $115 trillion. So we've had massive growth, and saying that healthcare is responsible for 30% of it is extremely impressive. So we're starting from a place where saying that we need AI to come in and rescue is really not accurate, because we're making progress. We're doing a lot better than we used to. Where I think Abby's 100% right is the fact that we can do even better. There are a lot of issues with healthcare around the world. One of the things that happened with my book was I went around the world promoting it. And when I was in the Middle East or Europe, I was meeting with ministers of health and learning about the problems with their healthcare system, because they wanted to hear from me how AI could help them with some of the issues they were dealing with. And what I realized is everybody is dealing with the same problems. The number one problem is shortage of resources. The population of the world is going up. The number of older people is increasing. When you get older, you're more frail. You develop more chronic conditions. So you need more healthcare. And we haven't trained enough doctors and nurses in the last 20, 30 years to keep up with the demand. So from my perspective, we need everybody who's working to be working, doctors, nurses, physical therapists. We need more people to be trained, and we need AI's help to be able to keep up with the demand, because the problems we're having with the shortage of resources are only going to get worse. The projections are the shortage of doctors and nurses is going to reach a crisis level by the early 2030s. So we don't need AI to replace doctors. We need AI to help doctors to keep up with the demand.
I agree with just about everything you said, but in this stance, I would frame it a little bit differently. Of course, we're not going to be getting rid of doctors by 2030. There's a lot of them, and they do great. So at no point am I going to try to put that down. What I would say, though, is you made an amazing point that there is nowhere close to enough trained doctors to deal with the world. The WHO estimates that roughly 4.5 billion people on this planet lack access to proper health care. And by the year 2030, there's going to be 11 million people deficit within like the healthcare space, that we just don't have that number of people. However, if we started right now and took 11 million people and started them on the process towards becoming a doctor, they wouldn't be ready by 2030. They wouldn't be ready by 2035 to any like good degree. However, what we can start doing is saying all of those things that we have taken and used to increase the life expectancy of the human race, that's our medical knowledge and application. And the real barrier to applying that to as many people as possible is figuring out what needs to be applied to who and how. And what we can do today, right now, in the next year, is invest a large percentage of that $150 GDP, $150 trillion GDP, and focus that on building new data centers, building new frameworks, building new areas of expertise that we could then use to say, you know what? 95% of the people who need medical assistance don't need a doctor. What they need is someone or something to tell them what to do, what to take, how to live, and be able to spend as much time as necessary to explain it to them, rather than have to go to their 40th patient of the day.
Great, thank you. So I'll move on to the next topic, which is, so there's an emerging debate in the world of transportation and logistics, which is that you may now have cars that drive more safely than people, and that raises the question for the first time: should we mandate? If we can measure the lives saved by having self-drive cars, should we start to mandate self-drive cars? So, to abstract this to healthcare and medicine, if a diagnostic tool has a higher success rate than a specialty physician, should it be mandated to replace the specialty physician?
This is a very important topic, and interestingly enough, it was going to be the next point that I made.
That was also good.
Let me mention that after spending 3 years researching and writing the book, and just to put a context on it, that I'm not an academician. Before that, I was running for 7 years one of the first digital healthcare companies, which added AI products towards the end of our life cycle. So I have run these companies, and before that, I practiced medicine, and I've seen the other side of it. In spite of the fact that I have hundreds of examples of use cases in my book about what AI can do in healthcare, in radiology, in pathology, in robotics, and so forth, in the final business chapters, I could not find 3 good examples of success of products that have been commercialized, been used in medical practice, and the companies are a spectacular success. Why? Because these products are showing a lot of good results with retrospective data that's been nicely cleaned up, and are showing theoretically how things work, but when they go into practice, they bomb, and they bomb badly. So we don't have good AI models yet that have been put to work in a hospital in the busy environment where the patient doesn't hold still. Half of their data is in a different electronic health record. And for it to see it deliver results in a way that is acceptable to the flow of how the practice of medicine was done. The fact of the matter is, you hear a lot about AI agents right now. I have recently, in the last few weeks, been at centers that are working with the latest and greatest AI agents. And I can tell you it's faltering in very basic stuff. So we need to be aware of the fact that what we hear, a lot of the things we hear about AI is not ready for the real world where things are very messy. I mean, Google published a study in JAMA that showed their diabetic retinopathy algorithm could look in the eye and say if the patient has diabetic retinopathy or not. And it was the study was so good that FDA gave it autonomous clearance, which means it can read an image of your fundus. If it's clear, you don't need to see an ophthalmologist. That's it. After they got the clearance, when they went into production, and this is in the book, in Thailand, one of their first implementations, more than 60% of the fundus images that people in the field, the nurses were taking, were not usable. Patients who are moving images were blurry and so forth. So unfortunately, we don't know when the promise would catch up with reality. That's why I think the real debate here is, will we get to a place where for a lot of things, we're not going to need doctors and AI could take over, such as this example. 2030 is really an arbitrary deadline. If it's not happening by 2030, but it happens by 2040, it's still significant. I would say we don't need to worry about 2030. The question is, can we get to a point where we turn AI loose to augment humans because we don't have the bandwidth to handle everybody we need to handle?
Lots of amazing points as always. I was going to bring up that diabetic retinopathy device, but it's actually really cool, the results we're seeing from Thailand. I think what that shows is a very interesting example of the nascent stages of AI and its applications. And when it comes to the application of AI in the general world, the question is, first, can it replace doctors in a given function for a given task? Will it replace doctors for a given task? And when will it replace doctors for a given task? The latter is a very big one because, as we all know, with healthcare, there's issues of data privacy, there's issues of regulation, there's all sorts of cross-compatibility problems. So it's definitely going to replace people way after it could have replaced people for any given set of dates that we're talking about. But what I like to think about a lot is mostly that first question of, can it replace doctors in general and specifically for any given task? And as Ron brought up, the first low-hanging fruit is really in the realm of narrow diagnostics. So when it comes to things like radiology, specifically looking at a retina, looking at various different types of scans. When was your book published? I'm curious. Last year. Yeah, I remember the launch part. Yeah. So, but if anyone here has been using AI in the last couple of years, who remembers the ChatGPT 3.5? Who actually used it? ChatGPT 4? And who's been using 4.5? How about Gemini 2.5 Pro? We got a couple. Claude 3.7. We got a couple standouts in the audience. When it comes to this type of technology, we're not dealing with linear growth. We're dealing with exponential growth. The things that AI can do today are way more than it could do literally at this time last month. You could have it create a full research report. You could have it go and look at images. You could have it do so many different things. When it comes to the realm of radiology, it's actually fascinating because I spend so much of my time pouring through medical research, trying to figure out, is a given thing, is a given technology, is a given product, device, compound worthwhile to use, to invest in, anything like that. And the gold standard, the top of the pyramid or bottom, depending on how you frame things, when it comes to scientific evidence, is a meta-analysis. It's taking large numbers of studies, combining their umbrella review, fine. You take the data from as many studies as possible and you combine it and say, what is our final result? When I was preparing for this debate, I was looking at the current state of the scientific evidence. And there are some meta-analyses that were published this month looking at various aspects of AI as it pertains to healthcare. On March 5th, there was one published looking at radiology outcomes. And they decided to include 33 studies looking at radiology results from 2020 through 2024. And the outcome, when they pooled all the results, was that at this point, the AI algorithms that they were looking at for the narrow instances, and this is not any type of radiology, for each individual study, it's like looking at mammograms, looking at stains from oncology, looking at specific types of radiology applications. And they found that that pooled result was that the AI overall did better than a typical human. 2 years ago, it was the absolute reverse. Another meta-analysis of around 85 studies looking at AI compared to doctors in general found that as of right now, AI did worse than a specialist, but around on par with a generalist for a lot of different types of questions involved. But the interesting thing about looking at a meta-analysis in this context is that they were looking at studies all the way from 2018, 2020 through now. And if you start looking at those forest plots, you look at the results of these algorithms compared to humans across time, it was getting better and better and better until the ones that were skewing things more in the direction of AI were the ones that came out in the last 6 months. As soon as you get to these AI from the last month, it's even better. And these are usually looking at pretty generalist models. As soon as you start taking the wheel and creating more and more specific models, it's going to be even better. And the future is really going to be not even a specific model. It'll be a constellation of models where first you go and get the whole case history for medical requirements. And then the AI says, okay, we need to pass you along to these narrow AI that have been trained on much more specific cases and get better and better as we go along. But the overall point here is that, yes, it's going to be individual use case, and the real world scenarios are super complicated, super messy. They don't always line up with the training data. But one of the cool things that AI tech these days is able to do is to take training from a given data set and start applying it to other data sets. As we get more broad, as we create these frameworks, it's getting more and more applicable where we can take a model and apply it to something that it was not directly trained for. That's why, to bring it back to your initial question with the self-driving cars, there have been hundreds of millions of driving miles clocked with self-driving cars to date. And most of them are in China because US regulation is not there. US trust is not there. People don't trust the machines. That's going to be one of our big barriers. And especially when it comes to things like our health, our medicine, for a given error rate, you're going to have the AI be 10 times as good as the human before we're willing to trust it with this same type of decision, because at least the human, there's someone to blame, there's someone to trust. Whereas these AI, if it makes an error that seems to be ridiculous, we will be really, really angry at it. So there's a much higher bar to hit. But we are moving on an exponential curve. And eventually we're going to get to the point where we hit the bar. And no one used to be comfortable using a GPS. You prefer to go and ask someone directions because you trust the human more than the GPS that says, turn a left, like take a left turn into that lake, because that occasionally happens. But we got to the point where now everyone uses GPS, and kids these days don't know how to read a map or know where they are in a given place. As humans start to trust the machines, then slowly we get to offload and then free up the doctors for more interesting things in a slow escalating process. I spoke for long.
Let me respond to this. This is a very important point about studies and what they're showing and their improving accuracy. The fact of the matter is, AI for assisting with rating mammograms, it cleared the FDA back in 2016, 2017. And before that, as early as 2010, there was CAD, computer-assisted diagnosis for mammograms, which got reimbursement from CMS and so forth. To this day, AI for assisting rating mammograms doesn't have reimbursement. If you go and get a mammogram done, and you want AI to be a second set of eye besides a radiologist, you have to pay extra $40 in order for that to happen. I mentioned I couldn't find a few good success stories for the last chapter in my book because a lot of these studies are being done in retrospective data from previous CAT scans and MRIs, nicely cataloged. They know which studies to pick. A lot of these, or almost all of them, haven't done real world prospective 1 year in production trials. This is why they're not getting reimbursement. Insurance companies are saying you need to show real world data that you're improving patient outcomes. If a radiologist reads this and can see what they need to see, and you can make them a little bit more accurate, we're not paying for this. If the hospital wants to pay for it, they can buy it, but we're not paying for it because you're not showing meaningful improvement in patient outcomes. Now you say this is exponentially improving and so forth. Let me tell you from behind the scenes. American College of Radiology moved in back in 2015, took charge of this process, is making sure not one dime of income from their members is threatened. In 2019, I got a call from a friend of mine from New England Journal of Medicine. New England Journal of Medicine hired me for a few months to advise them on whether they should launch an AI in medicine journal. And we worked on that project for a few months, and that journal has now been launched. As part of that process, I interviewed a lot of people, payers, providers, and the payers were very clear. A lot of these solutions are being approved by the FDA. FDA is not requiring real-world studies like they do with drugs and medical devices. You can develop an algorithm, train it on 300, and do a study where you say, here's 300 CT scans. I'm going to run it to see if it finds hemorrhage, brain hemorrhage. And I'll have 3 independent radiologists also read it. And I'll show that I'm as accurate as they are, which is what most of these studies are. And the FDA gives you clearance to start marketing this. The reality is, and I recount this in great detail in the book, Mount Sinai, Mayo, Stanford, when these algorithms have had any success gaining traction in a clinical environment, they've done very poorly. As a matter of fact, several of them have been shut down at Mount Sinai because they had too many false positives in the real world. So those studies, looking at how they were done, were they done in retrospective data or prospective, busy ER, busy radiology department, suboptimal images, and so forth, is what's keeping them from getting reimbursement. And as long as you're not getting reimbursement, you're not going to gain traction. So insurance executives told me it's the first time in my life where I realized what it feels like when everybody returns your call. Because I was calling on behalf of New England Journal of Medicine. Everybody was calling me back. I'm talking Minister of Health in China and so forth. And we were speaking with them. I realized developing the models is the first step in the process. You have to take this now into the real world, show that it works, that it can equal a doctor to gain reimbursement. And then, even then, you still face the adoption issue. Hospitals looking at it and saying, is this going to be revenue positive for us? What about how does it affect our margins? Is it going to meaningfully make our radiologists more efficient? So the barriers are numerous. They come in the form of fragmented information systems, regulatory barriers, reimbursement barriers. So having exponentially better models, I think it's a great place to start. But bringing technology into an environment where the providers aren't going to pay for it, it's going to have to be the payers. And if you're an insurance company, you're looking at about 1,000 FDA cleared AI solutions right now. How are you going to pay for all of this stuff? So you put a set a very high bar for the evidence that you need to generate to get reimbursement. And that effectively locks out a lot of these solutions because the VCs that funded them never realized they needed to fund real world studies like the devices and drugs.
Great, thank you. And so, by the way, for everyone, we have a lot of food here up front for now and for later. So feel free to quietly make your way up, grab some food. We ask them to cut them especially small so they have fewer calories. And so then next, so this is about the mistakes of AI. So we talked about a little bit about computer vision AI, which for 15 plus years has had extraordinary accuracy. However, there's a different category that we've all become excited about in the last 2 years, which is called large language model generative AI, totally different. And it has a problem. And its problem is that it is a black box of regression weights that gets things wrong and makes things up and can't explain when it got things wrong. And so we can talk about applying that to the language of administration in healthcare. So that's things like medical notes, scribing, coding, billing, prior auth, things like that. And I think everyone's willing to be wrong occasionally there. But then you move it over to the clinical world, and this is not necessarily a good companion for your doctor. Something that can hallucinate, for example. And so will generative AI, large language model, ever be adequate for clinical care? So we've heard so much from Ron. Why don't we start with you?
If you had asked me a year and a half ago, would I trust an AI with anything medical? I would have said, probably not. I would use it as a suggestive rule. Like it's something to figure out where to maybe ask the doctor or do more research. But yeah, the hallucinations were pretty bad. In the last year, there has been a tremendous amount of work towards both stopping the hallucinations from the models themselves, but also something called XAI, explanatory AI, where we want to design them in a way so that we can actually figure out why they said what they said. If anyone here has used ChatGPT, the O1 model, the reasoning model, you can actually look and see it gives you the reasoning behind what it's doing as it's doing it. Similar to the new Gemini models and Claude, you can see a lot of the thought processes that are going, and those are for models that are doing iterative reasoning where the human can track pretty well. There's a technique called lying, another one called sharp, where essentially what they're doing is, even if we don't know, like the model itself, so many parameters, it's a black box. Let me try to explain this in a very simple way. So what lying does is it says, this is an output. Imagine we were talking about a diagnosis for a radiology image. We look at the image and it says, oh, this is breast cancer. You want to know why it said it was breast cancer? Well, we don't know exactly what's going on in the black box. But what the lying method does is it says, we're going to take an image and we're going to modify one small portion, put it back through and see, does it still say that there is breast cancer or not? Then we'll take another bit and we're going to modify it a little bit. Does it say there's breast cancer or not? And by doing that, we can actually figure out which portions are more or less contributing towards that diagnosis in a way that even for the black box models that are not doing the progressive reasoning that's exposed, we're able to say, these are the reasons why this was diagnosed in this way. And then, doctor, go and look at that little bit. And actually, one amazing part is because AI are able to take so much data that a human could never process themselves. And we can now look at them and say, oh, what part of this data made you think it was this? We're actually seeing examples where you'll see some sort of radiology image which is diagnosed in a certain way. The radiologist first looks at it and says, I'm not sure why it said this. And then when you go and look back and see, oh, it was this little bit of like color shifting over here, they realize, oh, that's actually a type of inflammation that we didn't necessarily even realize was associated with this exact condition. And it gives more, it basically directs the human to go and figure out what's going on. And I think that's actually one of the really cool things to come out of all of this. Rather than replacing all the jobs of all the humans, instead it's saying, you guys now go and take what we saw from just like a observational perspective and try to figure out what is happening here. You conduct some more research, do some more scans, figure out why that was a thing. So in general, the problem of the black box AI, it's becoming less and less of an issue as we go forward. And before I continue,
First of all, I agree with everything Avi just said, but also let me mention to you, I have prescribed a lot of medications for patients where we had no idea how the medication worked. A lot of the things that are used in medicine, like we gave the Johnson for heart failure, we never had any idea how the medication worked, but at some point they realized this medication works. It was tested in a clinical environment. The side effects were manageable, so we used it. Some of the medications, like Viagra, was a medication used for pulmonary hypertension, and they noticed patients were having a pleasant side effect. So the idea that we absolutely need to know how AI is coming up with this recommendation, to me, makes zero sense, because for decades, we have used diagnostics and therapeutics in medicine where we couldn't explain how they did what they did, but it worked. The reason it becomes more relevant for AI is because of the hallucination problem. And if you're providing decision support or you're autonomous, not being able to separate which one is good recommendation, what is a hallucination, could become impractical, because if you don't have confidence in the advice you're getting, you're not sure, then you can't really trust it. What I will say to anyone who's using large language models for decision support, number one is nobody's ever made any money in medicine in decision support. The fact is, if you've practiced medicine, you know that 99% of your patients start walking, you know exactly what's going on with them. You don't need any help with the decision support. And a lot of these tools are being created by non-clinicians who don't understand this stuff isn't going to gain any traction in the real world. The scenario you just described, there is the AI reading the radiology scan and telling radiologists, go look this up and stuff. That ain't going to happen. They have a stack of radiology scans they need to read, and they need to get through it as quickly as possible because there's another stack waiting for them. Decision support may be helpful in certain cases, but in most cases, things are on autopilot. You need to get through the work that you need to do. The applications of AI that I like with large language models and otherwise are going to be applications that make physicians more productive or nurses more productive or take over doing some of that stuff. And what I've learned in the last month or so, visiting with centers that are playing with agentic AI, because you said you read my series. I wrote a series about agentic AI and the capabilities. And really what I was writing about of what the capabilities are, not the reality of what happens when you put them to use in a real world setting, is that the performance of a lot of these tools in the real world setting lags what their ultimate capabilities are going to be and what they're doing in more controlled environments. So lots of reason for optimism long term. Short term, don't believe everything you hear. See it as where we're going. Until something is taken into the real world, we see it perform consistently at a high level. We can't say that the jury is in. And the guy who wrote the foreword in my book, Professor Zolowitz out of MIT, before he wrote the foreword, he read the whole book and he marked it up, which is an ultimate gift to a guy like me, to have the father of medical AI reading your book to make sure you didn't write anything outlandish in there and people aren't going to call you out on writing wrong content. And where he dinged me several times was, the stuff you're saying hasn't been proven yet. Yes, it's being discussed, but we don't have real examples that it's being used and it's delivered consistently in the real world. So LLMs, transparency, I don't care about transparency. I care that it's tested enough and it performs at a level that the clinicians will trust it. And it can start taking on, it can get integrated into the workflow in a way that makes the lives of everyone easier. It doesn't need to take over their job. It needs to let them do their job in a way that they don't do certain things, or at the opportune moments, at the moments they need help, it helps them out.
Great, thank you. So one more moderator question, and then we'll have a couple audience questions. So this question, as a final moderator question, is about the future. And the question is AI overhyped or underhyped today? So you're at an interesting juncture in the general foundation AI model world where where Wall Street values these companies as the present discounted cash flow of future cash flows, and it's valuing them at a very high level right now. Enormous valuations for these companies, believing
not healthcare AI company.
So believing that they represent the future of software, and they'll be able to collect those revenues in someday. But there's doubt creeping in, and again, we're talking about the foundation models such as Microsoft Copilot, Google Gemini, OpenAI's ChatGPT, and the other Anthropic, the other foundation models, and they're saying, hold on a second. So you don't need these super deluxe GPU chips. After all, you can use cheaper chips. And a team of 30, working for a year with a $5 million budget in China can build something as good as OpenAI. So there's no software moat here. There's no hardware moat here. The value is going to be destroyed here. And so they're wondering whether the lift in stock prices we've seen in the NASDAQ in anticipation of future AI product revenues is going to pull in somehow. And so I want to transfer that to healthcare, which is a bit murkier. There's no public healthcare AI companies. There are some interesting ones like Hippocratic AI and Open Evidence AI that are out there. So is AI in healthcare today overhyped or underhyped from the perspective of 5 years from now? Is it going to live up to its billing and more 5 years from now, or is it going to disappoint us? And I would just point out that I got into digital health in 2006, and the burning question of the time was, can we get doctors to use email with patients? And now it's 2025, and most doctors still don't use email with patients. So things can take a little longer in healthcare than other sectors. And so why don't I start with you?
I started last. But I talked for too long. You go.
He never wants me to be able to respond. When it comes to the future of AI, I think with regards to the capabilities, 95% of people you talk to right now will underestimate the capabilities in 5 years from now. When it comes to adoption, they might overestimate it, especially within the medical realm. As we've been talking about a lot, it's so hard to get anything that works into a place that it can work. Which brings us back to that first question I was talking about. Can AI, will AI, when will AI? However, what I am very confident about is that the large stakeholders within medicine, within healthcare, they really like money and having people be healthy, but they definitely like profits. So the question is AI going to be able to be a provable path to profit? And I would say the answer is yes. Ron, you were talking before about the reason like that edge case in radiology will be useless is because they have a stack of images. Well, we are on the path towards that stack of images being processed by AI. Right now, there's cases to be made for either direction, real world, not. It is a foregone conclusion that AI will be able to take most radiology reports and be the one to process it with totally autonomous. There was a study published recently where they took radiology sample images. They had a doctor work with an AI by themselves or the AI by themselves. The doctor by themselves was in like 74% accuracy. Doctor plus AI, 76% accuracy. AI by itself, 90% accuracy. partially because doctors weren't very well trained in the usage of it, partially because they didn't trust when the AI said something they wanted to trust themselves. We are on the path where the narrow cases such as image analysis, radiology, that is going to be solved. It's going to be a long path towards getting it fully available, fully applicable, fully in use. What we're going to start with is the chimera, the combination of human and machine, where you have a AI model that is a general model. It's fine-tuned and trained to be able to do a particular use case. And its first goal is going to be to ease up the workload of a given type of doctor. When it comes to a radiologist, if the AI can do the first pass processing of a whole bunch of images, and all the radiologist has to do is yes, no, that is faster than them doing the initial analysis. I'm sure you can make some various points around that, but overall, it's easier to look something over than it is to do something initially. And almost any use case of AI within medicine, we're probably going to be seeing something along those lines, where the AI will first work in concert with the doctor. The doctor will always need to be giving a final pass approval or disapproval. But when we have that data, especially for the large healthcare systems like Mount Sinai, Mayo Clinic, if they're able to go and take that yes-no data from the doctors as they slowly start using these tools, use that as a feedback mechanism to say, you know what, we have now hit the point where the AI is doing so much better than the doctor that it doesn't make sense to have the doctor be the final pass. That's when we're finally going to start seeing certain applications of AI replacing the doctors for those tasks. And there are going to be regulatory hurdles to pass it. There's going to be all sorts of maybe union issues, who knows? But technologically speaking, we will get to the point where for all these narrow processes, the AI will be able to do it. But I think that's actually ignoring one of the most exciting aspects of AI in health. And that's something we haven't really discussed yet, which is fundamentally the institution of medicine for the last 150 years has been all about how can we minimize the effort required by a doctor for the maximum impact, because there is never enough doctors. And part of it is when you have a blood test, you're looking for the types of blood tests that are the most able to give you a decision for something that's going on with the patient. You want to look at the HbA1c and say, oh, this person has okay glucose control, pre-diabetic, diabetic. You want to look at their blood pressure, which is all sorts of things. Metrics that themselves are very diagnostic of medical conditions. What they don't want to look at is the organic acids in your urine and try to figure out which metabolic processes are going to an individual outcome that's likely linked to 1,000 other little biomarkers. What humans are really bad at is processing 1,000 biomarkers at once. It's why genetic analysis has barely made its way to any sort of medicine, because aside from particular genes like ApoE or BRCA, in general, it's a whole constellation of effects that are really hard to pick out individual use cases from. But we are starting to see a shift where we have these AI tools that are going to have access to all of the medical literature. But soon, as we start developing systems, techniques, devices, feedback loops, where we're able to give the AI everything about a person when it comes to both their psychosocial, environmental, and diagnostic. If we can start measuring hundreds, thousands of biomarkers and feeding it all in, reporting back the outcomes, these AI tools will start being able to diagnose things in a way that no human could ever do. You're saying that 99%, 90% of patients that come in, you know what it is. Well, you know what? Sometimes those 1% have been bounced around through 30 different doctors across the last 10, 15 years. And because they can never get every required specialist in a room who can all talk to and bounce things off and figure out how the systems interact, they're never able to get a solution. There are so many individual case reports now of those sorts of people putting all their information into these AI systems and getting a recommendation that no doctor was ever able to find, because you don't generally have a specialist across 7 different fields. The future of AI that people are not really able to predict right now, and that I don't think enough people understand, is that medicine is going to start converging in a way where we can process all the inputs, all the problems, and figure out disconnected causes, subtle causes, unique causes that are precise, precision medicine, where we can customize each solution to each patient, not based on this worked for 1,000 people, therefore it'll work for you, but this worked for the one person with all of these things, and we understand every process, and we can get it there. It's going to be a long time before we can get that because of regulatory hurdles and validation and all of it. But I am very excited about that particular aspect of AI in medicine.
So I think the reality for those of us who've been in healthcare for a long time, and you could say one of my favorite expressions is I've been abused by everybody in healthcare. I was a physician, then I became a consultant, then I was a vendor selling to medical centers. I was selling to my old partners. I was a partner in a cardiology group, the largest in the country. 2 years later, I show up selling software, and now I'm being treated like I'm the enemy. The reality is the business of healthcare is very difficult. It's challenging. Capabilities of AI are gonna expand exponentially, and AI theoretically could do a lot of things. But it's running into the meat grinder, which is the practice of healthcare. Hospitals with thin margins, don't have a lot of resources, don't have a lot of bandwidth. They're going to be very careful with what they buy. And to your question, is AI overhyped or underhyped? I think, first of all, in healthcare, it's been tough going in terms of there were some lofty valuations in 2020, 2021 when interest rates were 0%. And there's always this issue of these big, lofty promises of AI. I mean, I was on Power Lunch on CNBC a few months ago. Tyler Matheson, this sort of long-term CNBC reporter, asked me to come on. And I was conversing with him the day before I went on TV and about what to talk about, because these reporters, obviously, these anchors don't know anything about the topic. So you debrief them ahead of time. After spending half an hour, talking about, administrative and operational use cases are the way to go right now. The next day, when I was on air, the first question was, Jamie Dimon said an hour ago on this network that AI is going to cure cancer. What say you? And what the hell? We talked about this. Then it's funny. Right before Christmas, I was going on Fox Business on Clayman Countdown with Liz Clayman to talk about the assassination of the United Health CEO. And the producer emailed me as I was leaving my apartment in Tribeca to go to their studio, Fox Studios on 6th Avenue, and said, can you have a few public health AI stocks that you can mention on air for our audience? I was like, okay, well, Tempest went IPO, and our Waystar was also another. I'm like, these are two sort of healthcare AI-ish stocks I can mention, but also Nuvo had gone public. And somehow, by the grace of God, as I'm leaving my apartment, I'm like, let me check these stocks to see if they're doing well, if I'm mentioning them on air, on TV, on national TV. And sure enough, Nuvo had already gone bankrupt. Like 3 months after going public, they were already bankrupt. I was about to go on national TV mentioning a stock which was no longer. So I think long term, I agree with Avi that AI is going to be a powerful tool. Whether it's going to become autonomous or not, I don't know. But I know the buzzsaw and the meat grinder, which is American College of Radiology, American College of Cardiology, the FDA, the decision makers in healthcare and insurance companies, and the solutions that can navigate this very complicated maze are going to get adoption and are going to do well. The rest aren't going to do well. And these solutions are being created by a lot of people who don't understand the business of healthcare. And that's why a lot of these companies are not making it. So if the valuations are being overhyped because they think those cash flows are going to happen in the short term, it's overhyped. If it's based on the long-term promise of what it could achieve, it could be 3 years, 5 years, 7 years. I have no idea. I write in the preface in the book, I make no prognostication. I don't know when it's going to happen. But I think it's going to be, if history has any lessons for us in healthcare, it's going to be slow. So it might be a bit overhyped based on short-term cash flows, but long-term, I 100% agree with Avi that the technology is too powerful not to take a central role in how healthcare is done.
We can go to questions.
Great, thank you. So for our audience, please raise your hand, come forward, jump in. Jacob, would you have ask a question?
Yes, give you the because it's been a sure thing. Thank you.
So the meat grinder, I absolutely completely agree with that. So 30 years in healthcare and technology, previous senior executive, one of the largest payers in the country, and I absolutely agree that I don't think that the change is going to come from the industry. So my question is, how much of this change, and will this change be different from the consumer perspective? From folks who don't have access to care, as you mentioned earlier, will we see adoption be driven more by consumers or more by the industry itself? That'd be grand. Please.
Let me just mention, if you watch what's happened in the last few years, consumer healthcare is a famous graveyard. So digital therapeutics were a promising category a few years ago, using digital tools to treat chronic pain, anxiety, and so forth. Every one of these companies went bankrupt. Even if they went through the FDA, Care Therapeutics was the poster child for doing it the right way. They went through the FDA. They did prospective real-world trials with control arms. They went public via SPAC for $1 billion. A year later, they went bankrupt. They sold all their assets for $6 million. Man, you can't do it better than Pear did. So the fact of the matter is, for digital therapeutics, and some of them which were sort of non-prescription therapeutics, apps which you could use for anxiety and so forth, that's now the FDA is coming in and saying you have to come through the FDA. They gave some leeway with the pandemic because they wanted to make the mental health tools available to the public. But that path is now being closed. Also, a lot of these companies have realized consumers aren't going to keep paying a monthly $20, $30, $40 bill. They stop after a few months. They need to get insurance reimbursement. Insurance reimbursement means a provider is going to need to prescribe it. And that means real world studies and submitting to CMS and so forth.
So let me actually throw in something there. I want to draw a distinction between rich countries and poor countries. The U.S. is a rich country, and in the U.S., if you have a better, CT scan, AI computer vision analysis tool, then you have to go through proper channels, and there's going to be a radiologist who could be a blocker, and you have to get this reimbursed somehow, and it's an extra cost in the system. But if you go to a poor country, like say India, the choice is to have a primary care physician and never to have a radiologist, but perhaps to have a CT scan with an AI read on it that goes back to your primary care physician that is consumer pay. You pay for that directly. So you may see some of these tools take off in poor countries, and then you may see them gain scale and gain large databases and then outperform tools in rich countries. And so it's sort of like the empire strikes back.
I think it's a great point. As I said, 4.5 billion people don't have good access to healthcare. In general, in the US, you can walk in and get a specialist wherever you want, but the access to a digital technology that you don't have to worry about red tape, you don't have to worry about whether or not you can trust it because it's all you have. That's going to be a game changer for so many people.
But let me also add, since I used to work at McKinsey for a number of years in consulting for medical device devices companies and pharmaceutical companies, it's very difficult to make money in this. If your stock price is predicated in them using it in India, you're in trouble. Like Medtronic used to be my client, and we would bring up how many people needed pacemakers in India. And they told me one time, and we charge $7,500 for our pacemaker here. In India, it's $200. So when we modeled a new drug or a new device, when I was at McKinsey for our clients, it was US was usually responsible 40, 50, 60% of the worldwide sales. Germany, France, Italy, Spain, the EU5 was the next 20, 30%. And then all we get is plus 15 to 20% for the rest of the world. So these are, you made all your money in these six countries. And with AI, as you're mentioning, in Africa and India and a lot of these places, there's just not going to be a lot of money to pay for an algorithm reading a CT scan. That's not.
Hey guys, can you hear me?
What I will say is, I went to the Middle East for the first time with my book tour, and I saw rapidly developing countries there, where there is a lot of money being invested in modernizing their economy, including their healthcare delivery systems, and they're seeing AI as something that can help them leapfrog sort of the legacy systems like ours, which were built, in the last 50, 60 years.
Will, can you come forward?
Sure.
This has been an absolutely fantastic debate. I just wanted to ask, what about the patient? What does the patient ultimately want? Because we've been talking about it from the perspective of the payers, the perspective of the markets, the perspective of investors, and the product makers themselves. But what do the patients actually say in terms of, do they want the AI to listen on their conversations? Do they want the AI to assist in their medical diagnostics? What are they saying? That's what I think is just like not really been touched upon too much in this our whole debate, but it still is a very important issue because there's essentially 50% of the care and of the product that goes into like the whole practice of medicine when we think about it.
Right now, there have been a lot of studies looking at essentially surveys asking people, would they trust a human? Would they trust a doctor? Would they trust a hybrid? Unsurprisingly, across the board, right now, everyone's going to trust a doctor over an AI. And that's as it should be, because we're still in the nascent stages. So that's totally fine. However, who here has asked ChatGPT a question about medicine or health? Show of hands. A lot of people, because it's on hand and it knows a lot. We are very slowly training a population to really realize just how much it knows about medicine. And the role of the AI within the healthcare system is going to be to have regulatory bodies force companies to really do the due diligence to prevent the hallucinations, to make sure that it's reliable enough to create a full diagnosis. And at that point, the consumers can be able to say, oh, it is validated and I will trust it unless the doctor says otherwise. It's going to be a slow process of learning to really trust it. But just like, as I said before, you didn't use to trust the GPS until you started to, humans are very good at adapting to things, especially when those things make life easier. And AI over time is going to make life easier, and we're just going to start getting used to trusting.
I agree with that.
But we're in New York City, so we're all very well, educated and well informed, and probably know how to self-advocate for healthcare. But there's many parts of this country where people still don't trust their doctors or seek out healthcare or even use the internet. So just because the technology is available, maybe it's failing because these companies are leapfrogging, seeing like an opportunity that isn't accessible to most people, and the mindset's out there. So how do you address that? I mean, how can you use AI maybe to make medicine and healthcare more accessible for people who don't trust the current system? Does that make sense?
Yeah. You raise a great point that a lot of people have serious trust issues, as we all know. When it comes to those sorts of people, obviously, they're not going to go and ask ChatGPT a question to help them, but if they don't even have internet. However, one of the things we've been talking about a lot here is ChatGPT and AI in general, being able to take the low-hanging fruit to free up time and ability within our healthcare system. We haven't even discussed the ability for the real low-hanging fruit, which is do notes, to do prior auths, to do things that free up so much administrative time and just make things communicate better, free up the time for our healthcare system to be able to do things like go out and talk to people, spend more time with them, get them to trust a human, forge that connection, and down the line, maybe that will benefit from AI. But those people are going to benefit if we can free up slack and capability within our healthcare system, which AI is poised to do. I think it's the biggest way it can have an impact.
I agree with that 100%. I think the low risk use cases, like AI scribe, coding, prior authorization, which frees up resources to spend more time with patients. I mean, I pay attention when I go to see my doctors. They come in, they log into their electronic health record, and they're typing, and I'm paying very close attention. I can't remember the last time the doctor looked at me. They're typing their note, and I know what's going on. I've been in their shoes. There's a line of there's a line of patients waiting to see them, so they want to capture that information while it's fresh on their minds. So I think going back to your point around discounted cash flows and valuations, companies that use AI in these low-risk use cases, which doesn't require FDA, it doesn't require reimbursement, but it can improve productivity of staff, it can improve burnout. Those are excellent use cases. They're going to deliver value. They're going to deliver for the bottom line. And to me, it's also going to foster trust amongst doctors and nurses, where if something is helping you out, if you used to write notes and now you're not writing notes, if it's keeping an eye on your patient, ambient monitoring, and you don't have to check on the patient every 10 minutes, you become more open to its clinical applications because you've seen benefits. So starting off with these low-risk use cases that help people and make them comfortable with AI, there's nothing wrong with that.
Just to say very quickly, the reason I was being rude to take down my phone here is because I'm wearing 3 AI voice recorders right now, and I have a full log of our entire debate. I can ask it to give me a summary, bullet points, mind map, itemize it. That's what's happening within the doctor's office, or can be very soon.
I mean, the AI scribe is the first widespread use case that we're seeing. That's within the last 2 years has really taken off, and it's, I would say, the poster child for a good use case that's gaining widespread adoption.
Thanks. And Tony, did you have a question? Or
We have
you have like 2 more, Tony, and the person.
It's actually a follow-up to Will's question about the role of the patient. And so, when you asked the question around, who in the audience has used an LLM to ask the clinical question, actual case study to share the group later. But it seemed like a good number of us have, and in a way could be helping us visually generate more trust in the output of these models. With enough consumers and patients in the market using ChatGPT or Claude as a second opinion, the level of trust can go up, right? Where do you think is the role of patients in generating that demand and applying pressure against some of those lead grinder stakeholders you mentioned?
I would say patients aren't going to be able to do diddly-do on getting a hospital executive to buy a technology for which they don't have a business case. And Alex and I have been talking about this for years. Payers forcing doctors to do anything. This has always been, payers are going to get the doctors to do X, Y, and Z. I ran a population health management software company for 7 years. We sold enterprise software to my customers for Ascension Health, Kaiser Permanente, Montefiore. let me tell you something. I started that company because after the ACA passed in 2010 and there was talk of value-based care, a new form of practicing medicine and stuff, I was stupid and naive enough to believe that stuff. After years of selling that software to those customers, I realized none of them really wanted it to work really well. Because if it did, it would lower traffic to their emergency rooms and hospital rooms and ICUs and so forth. And when we're doing due diligence on companies now, and some of those business models are similar, and we speak with these hospital executives, we realize nothing has changed. 93% plus of their dollars are coming from fee for service. That's how it's going to stay. And I made this point in a moderated debate that I did with David Berger, who's the CEO of SUNY Downstate Medical Center, about managing patients proactively, value-based care as a way to fix our system, which is higher expenditure per capita than any other OECD country with worse outcomes. And by the way, none of them are doing value-based care. It's all fee for service in Canada, Germany, France, but they have much lower cost of care and much better outcomes. So why are we inventing this whole thing around value-based care, which, let's say a provider, a doctor, or an institution does everything perfectly. However, if the patient doesn't follow what you've asked them to do, you're out of luck. They go back and start smoking again. They don't take care of the wound they went home with, and now they get readmitted. And you're going to ding the hospital and the provider for something that the patient did. So it's important to understand how hospital executives, health system executives, payers look at their bottom line. They carefully analyze what technologies they use. And the information disparity between doctors and health systems and patients is too high for patients to come in and pick it outside Mount Sinai that you need to use AI and you need to use AI now to take better care of us. That's not going to happen.
And then it's Carolyn, you'll go next.
I think you mostly answered it already. The question was more instead of AI facilitating or helping doctors, how can it help unblock some of the bureaucracy that makes access to healthcare inequitable and inefficient, more expensive than it should be?
I think the lowest hanging fruit there is sort of what we already said in terms of freeing up administrative capacity. There's going to be a lot of ability to go and make use of the full electronic health record, which the vast majority of it never actually sees an input. The number of times I've been to a doctor and they say, "Oh, you got an X-ray 3 months ago. We're just going to do another one because we don't really have access to that." The ability to go and process a whole data dump and give that in a structured manner to whoever needs it, that right there is going to be simplifying the process and increasing access to the other things that right now are in the bottleneck. So the more leeway that we can produce within this system, the better. And as Ron has been saying, it is a very large hurdle to get the actual digital diagnostics and very applicable stuff there, but it's very easy to make a case for any sort of hospital or health system that we're going to lower your administrative costs. We're going to lower your overhead. We're going to lower in very defined bins. If you can prove a monetary gain, again, with radiology, that's the thing. If you can say radiologist time is going to be spent a lot more efficiently, they're not going to have to pay as much of it. That's a very easy one to say. When it comes to value-based care, that's a much, much higher hurdle. But as soon as we can lower the overall cost involved in a lot of the things that humans are doing repetitively, humans are doing inefficiently, humans are breaking down the communication, then suddenly that will save money and increase the ability to spend our healthcare dollars, effort, and attention on the things that make a bigger difference for human health.
So I'll just add to that. So there's a saying in the world of technology that you get a breakthrough in higher level user adopters when you get a better user interface. And so an example of that was when PCs were run using the DOS operating system, you had to be an expert in text prompts. Not a lot of people were. When they switched to graphical Windows operating system, then more people could figure out how to use computers. So likewise, we all have a relationship with our providers, whether it's calling them on the phone, visiting them in the office, interacting with their website, calling the head office, that sort of thing. And I think that in the future, that could be a chat GPT-like interface with them that addresses this particular medical practice, but also your medical questions in general. And your life might have your own data stored on it. And that is a user interface breakthrough that could allow people to engage with their health better.
One last quick thing. Another very big problem right now is medical error. And I think one of the really cool uses of AI is going to be to act as oversight and help limit and prevent that. There's a lot of times when someone gets prescribed something and they mishear it over the phone. They get the wrong medication just because it sounds similar to a different medication. And no one who's processing it in between necessarily knows how different they are. That's a very easy, low-hanging fruit task for an AI to say, you know what, that medication has nothing to do with the rest of their chart. Let's put a kibosh on it. And that can have a very large impact immediately.
Great. So, Carolyn, what to?
Hi there, Carolyn, former PwC consultant. I'm really happy that we talked a little bit about the patient in all of this. I want to discuss a little bit about the legal implications around AI in healthcare, specific to, like, let's say there's a misdiagnosis, who would be legally responsible when it comes to AI or anything else around just legal matters.
This is really easy. It's the provider. So you can use whatever tool you want to use to do your job. The output is what you're responsible for. So if you're going to have AI read the X-ray, you can. But if there is an issue, it's your ass. So X-rays, by the way, let me mention something, and this will eventually be conquered in terms of X-rays, because you mentioned X-rays being a good use case, and it's a good narrow use case. If you have an X-ray or a CT scan, you can train AI to read whether there's tumor on it or hemorrhage. However, if there are other issues and the algorithm hasn't been trained on it, it's going to miss that. If you've trained it to find disc herniation and then there's a massive tumor sitting right there, it's going to miss that. So the future where AI takes over for reading the scans needs to be multiple models running to look for everything. And that seems to me like it's far away, where you have you've stipulated every abnormality that could be detected, and you have a model for it that you run. Right now, a radiologist looks at it and may see something in the soft tissue that's out of the ordinary, even though it was ordered for a disc herniation, and that's commented on and it's followed up on. So even in those narrow use cases, radiology right now needs to do the overread for everything else on that X-ray. So coming back to your question, no matter what AI does in a clinical case to assist you, you're responsible for the output of what happens. You can accept or reject AI's advice, but if something bad happens, it's the provider in this institution. This is very clear.
So let me just add, so I actually think that this is the final role of the doctor, is to be responsible.
We can't be.
Today, doctors are experts, but AI may be a greater expert and replace a doctor in the role of being an expert. And today, a doctor may be an authority figure and AI may be a greater authority figure. But when it comes to our health and our lives, we want a human to be responsible to address chaotic data, to address conflicting data, and to make a decision and be responsible for that. So
I agree with all of that. There's one quick point I'll add, which is that we're going to have to view this from a very actuarial perspective, and it's going to get a little bit weird, because when it comes to humans making errors, a human might think that a tumor is benign or not, and they'll make the call. And if it turns out the other way, maybe the person will sue the healthcare system, and maybe they've got insurance to handle it. And it's a very normal process. But humans think in a very structured, logical way. It's possible that the AI will look at that and say it's a tumor. They might say it's benign. They might say it's not. But they might say, I don't know, that's a duck. And you have no idea how it said it was a duck. But sometimes it works in weird ways. That particular case likely won't happen. However, when it comes to figuring out, do we apply this, do we not, who is legally accountable? The question is about the error rate of the system as a whole. And if a doctor makes a mistake 5% of the time, and the AI will make a mistake 1% of the time, then the insurance company that's going to be handling all of that, the provider of, there's going to be some sort of insurance relationship between whoever makes the software and the payers and the doctors, and that's going to all be worked out. But it's going to be very much based on the numbers in terms of the error rates, the magnitude of error, what the downstream implications are. And even if some of the errors end up being a little bit weirder than the doctor may have had, as long as the overall error rate is lower, then it's theoretically a good thing to adopt. It's very similar to the self-driving car thing we were talking about earlier. Humans get into car accidents all the time. Self-driving car tech is already at the point where it's better than humans. But humans don't trust it because they want to be able to point and blame a driver. They don't want to be able to say, oh, this AI system has an acceptable error rate.
But you're missing something huge. Lawyers can't sue AI. So the doctors.
You sue the company that made AI, who has insurance to handle lawsuits.
Yeah, how are the lawyers going to be funny?
Oh, they're getting kicked out before the doctors, though. AI lawyers are great.
All right, you announce the winner.
yeah, thank you. So everyone, so I have a challenge to you all to meet 3 new people here tonight and get a name tag. It's more social if you're wearing a name tag. And let's give a round of applause to our 2. We have a lot of food up front. Don't forget about the food. And Reba, you asked a question tonight, so I wanted to give you our door prize, the signed copy of AI Doctor.
One last thing, I'm going to close this out with a little song that I wrote about Ron and his book and this debate. And by me, I mean an AI, and turned it into the full thing. Because if you think AI progress is bad or slow, I don't know if you've heard what's going on with the AI music, but just like it used to be absolutely paradigm before. Let's see if this works. I'm wearing headphones that I need to turn off. Is this not going in? All right.
Gotta book your biopsy. Said AI helps talk. Oh golly gee. Reads your scans, got the cough, checks your heart rate. Says humans are needed, bit out of date. He details the views, the data so messy, but the algorithm's hungry. It just won't say bless me. Oh, doctor. Doctor beep boop beep. While human docs lecture, AI doesn't sleep. Pathology is cautious and not a replacement, but the code's getting smarter in your basement. Hi doctor, your future is sealed. Your diagnostic skills are about to be repealed. The ski lists, regulations, the workflows, the cost, tiny hurdles for AI, your relevance lost. With federated learning and LM so grand, they'll analyze data right out of your hand. Forget intuition, forget your gut feel. The AI diagnosis is perfectly real. Oh, doctor, AI doctor, beep boop beep. Human docs lecture, AI doesn't sleep. Doctor is cautious, says not a replacement, but the code's getting smarter in your basement. Hey doctor, I doctor, future sealed. Your diagnostic skills are about to be repealed. So long, doctors, it's been quite a run. Your AI successors work has begun. If you learn to read through the AIT, the robot universality.
We could send it out. Anyway, thank you guys all.